Hello everyone, this is Gyaneshwar Sairam and this is my DS Techtalk and my topic is a data structure for manipulating priority queues. So, what is a priority queue? It's an abstract data type ADT that operates similar to a normal queue except that each element has a specific priority. The priority of the element in the priority queue determines the order in which the element is removed from the priority queue. Note: it only supports comparable data, means the data inserted into the priority queue must be ordered in some way, either least to greatest or greatest to least. This is so that we can assign relative properties to each element. Priority queue, which assists stocks company restricts company should purchase for investment. Priority queues. Many factors determine the future values of assets. Let's call the utility. Utility assets is equal to priority or importance that utility returns the minimum value. Use utility as a key or the order of assets in the list. Definition of the priority queue. It's an abstract data type, stores collecting of prioritized elements, supports abstractly element insertion, removal of elements in order priority. Priority queue ADT. Each entry is pair of key value. Key used to identify or weight the each element. To distinction entries in the priority queue can have the same key. Mathematical concept of the total order is the reflective property k less than or equals to k, and the antisymmetric property is k1 less than or equals to k2, and the transitive property is k1 less than k2 and the k2 less than k3. Main methods of priority queue ADT is size method, returns the number of entries in the queue is empty, tests whether the queue is empty. Min returns do not remove an entry with the smallest key. Insert k of x. Insert an element with a key and a value. Remove min. Removes and returns the entry with smallest key. Sorting with a priority queue. Sorting a collection S or of n comparable elements with a priority queue can called priority queue sort. Hint: using insert and removal method. Implementing a priority queue with an unsorted list with 4, 5, 2, 3, 1 as elements. Insert ADS adds entry at least at last takes big of n. Removal min requires complete scan of time complexity takes big of n. Fact insertion and slows removal. With a sorted list, insertion requires complete scan takes big of n. Removal min always acts the first element takes big of 1. Fast removal and slow insertions. Size is empty. The time complexity is goes as big of 1 to big of 1. Insert big of 1 to big of n, and the minimum or remove element. The best case is big of 1, the worst case is big of n. Sorting using priority queues. Selection sort or insertion sort. This is selection sort. We have elements 7, 4, 8, 2, 5, 3, 9. In the first iteration, the sorting happens. The 2 is placed in the minimum position. And in the second iteration, the 3 is placed in the second position. And in the third iteration, the 4 is placed. And in the fourth iteration, 5 is placed. And like that, in n-1 iterations, all elements are sorted. The runtime of the selection sort algorithm is: first remove min takes big of n times, the second remove min takes big of n minus 1 time, and so on till the n operation takes big of 1. The time complexity goes as big of n plus n minus 1 plus so on plus 2 plus 1, that is equals to big of sigma of I is equals to 1 to n, that is equals to big of n2. n square. Insertion sort. We take elements 7, 4, 8, 2, 5, 3, 9, and in the first iterations the 7 and 4 are compared and 4 will be remains. In the second iteration the minimum elements at position at the first index and so on. At the n minus 1 iterations the all elements are sorted. The runtime time complexity is first element no comparison and the second element one comparison, third element two comparison and so on. So big of 1 plus 2 plus so on n minus 1 plus 1 that is equals to big of sigma I is equals to 1 to power of 1 to n that is equals to big of n square. Complexity of reticles. Operations. Insert is a sorted array is time complexity big of n. It's an unsorted array the time complexity big of 1. Deletment. In a sorted array the time complexity is big of 1 and in unsorted array it is time complexity big of n. Union and update. Okay, we can see it's a what is a as n square is a time and it takes too much time. We don't as it takes too much time big of n square we are using another data structures called binomial forest to reduce the time complexity. What is a binomial forest? Actually binomial forest is a collection of binomial heaps. A binomial heaps is a forest where each item is a node. If A is a parent of B, then the value of A less than or equals to B. That is the rule. And here are different types of binomial forest. First, a binomial forest is rank 0, and second is rank 1, and the third is rank 2, and the fourth one is the rank 3, as the number of branches connected to a node is 3. In the binomial heaps, the all operations takes big of log n. The operation of binomial queues. The union operation. When the two binomial heaps are of same rank, we can union them by in here we take 7, 12, 8, 13 as one heap and 3, 4, 5, 9 as another heap. As 3 is less than 7 and 7 becomes a child node of 3. And in insert function add a singleton tree of the forest that repeatedly merge trees of equal ranks because there can be most one binomial tree of any degree big of log n. For example, here we have two trees that are 12, 7, 15, 25, 28, 33, 41 and we want to insert 6 in it. As 6 is rank of 0, here we can find 12 also rank of 0 and we know that in binomial forest no binomial trees exist with 2 ranks, so we can merge 12 and 6. As 12 is less than 6 it becomes a child of 6. Here again 6, 12 and 7, 25 are of same order 2. Then again the merging process will take place and the 7 become child of 6 and then 6, 7, 12, 25 and 15, 28, 13, 41 will of same order. Then again merging process will takes place and the branch 15 is as becoming a child branch of 6. Delete min. In a delete min function, we have to delete the root of any tree and then all its children become individual trees. Now merge all the equal rank trees. To delete a minimum, if you want to delete a 15 from the tree, first you will delete 15 from the binomial tree. Then the all trees are individual. Now we have to join the each tree with the same rank and as a result the tree becomes 12, 7 33, 25, 28, and 41. Implementation of binomial process of binomial tree. It is not possible to code these algorithms on digital computers, so we implement binomial forests as binomial trees. 725. As 15 is less than 7, then it becomes like this. Applications: standby flyers, auctions, and stock markets. The applications of priority queues, one of the special applications of the priority queues is graph algorithms like Diksha's sorting path and Prim's minimum spanning tree. Thank you.